Good morning, everyone. Okay, so how was your day yesterday? Is it good? Okay, having fun in that conference? Okay, so we are going to start with lab review again. Today we have Hana. We have FabLab Taipei. If my memory is correct, we have FabLab Taipei, and who do we have? Yes. I remember your workshop day. So mischief making, right? So one maker group. How do I pronounce AKGC FabLab and FabLab Mindanao? Jay is going to talk about his project too. So should we begin with FabLab Taipei? Yes. Could you come up?
Hey, morning, everyone. I'm Ian from FabLab Taipei, and sorry. Oh, last year we moved a new space and organized. Our location opened at the end of last month, and this is our space. And last July, we worked with GigaBay and carried out a challenge. And we have done a lot of workshops for people of different ages, such as make a paper maze, the workshop, and set. Sorry. On October the 2nd, a group of students from Singapore, and we take them, make their own door and install. And if you use the needle to stab the door, it can make your recoil sound. So it's Singapore students, college student. And last year, there is a community sketch and line. The community composed of a group of people who like to draw and they get together every weekend to draw and community. And after we opening, they start getting in our makerspace and learning how to make the painting to other things with digital machine. And there is a large break wall in our space. So they work together to draw the wall for 2 days, and they make the space look more interesting. And let's see the video about the process of their creating. And let's so nice, and now the war is and yeah. Okay. Oh, okay. And the last year Maker Fair Taipei is the last November. Fair Taipei assess the speech and the state. After the makerspace, we many Freudian friends and come to our makerspace and to meet. As a party, we possess very Chinese and Taiwan's food. On the other hand, we have another space that we also opened last year. It's New Taipei City Makerspace and Tour Library. It's in New Taipei, and Fair Taipei is in Taipei. And there are different teams in the space, and they have their own strangers. And last years, we retired 7 teams, and this year we is 10 teams. Some of them are engineers, metalworking artists, maybe it's table game design, or letter artists. Sorry. The letter artist is a worker space. And it's towards library too. So we have many working tools in our space. And people can come there. People can come here to learn how to use the machine and also borrow the tools to create their project. So we make many classes to teach them to use the machine. Let's see the video about the New Taipei City Makerspace and Tour Library. Maybe the other file. Okay, thank you. Okay.
Sorry.
He is a teacher. As a badminton working artist. As our own machine. Is end. And this is the end of my presentation. Thank you very much. And this is my first time to presentation in English.
Hello, good morning. 안녕하세요. My name is William. I'm from Singapore, and I'm with. I'm not from a Fab Lab, so it is quite awkward to talk about this in a Fab Lab review. But nevertheless, I think we share a certain similar philosophy and similar ethos, so you'll find something very familiar. So while we may be different, but they are similar. My company is called One Maker Group. So in short, it is OMG. There is a reason. So if you maybe tonight under the influence of alcohol, we can explain why it is called OMG. So, yep. First of all, this is how the world sees the country that I live in. Awesome, isn't it? Looks modern, looks beautiful, looks expensive, you know. But in reality, this is where I live. Majority of people in Singapore, or 80% of them, live in a pigeonhole type flats or apartment, no bigger than 1,000 square meter, you know. So we don't see a lot of beautiful things around us, right? Majority of people are very contented with very, very simple things. The reason I share this is because we don't start from the grand scheme of things. We start from a very simple, ground-up perspective. This is what we see, and because of the way we live, you know, we live in very small places. So sometimes our thinking tend to be small and tend to be, you know, not so wow as what we would want to be. I happen to have the privilege to work in a very old building, a relatively old building in Singapore. This is called the National Design Center, and it is probably more than or close to 100 years old. It used to be a school started by some priest or nun for some Catholic missionaries to help poor people to have proper education. That was like more than 100 years ago. So what happened is that after some years, the government decided to restore this place into a government building. So this is where government agency together with a private enterprise can come together and, have interesting relationship to create interesting things for Singapore. So this is kind of like where I work. And this is the space that we are currently at the National Design Center. As you can see, it is very messy, right? And in fact, this is actually the neatest. You look at the corner on the left, that is actually the neatest part of our space. That is actually the gallery area where we have a lot of cardboard and products, and all the messy places we don't even take photos. So you only see this. But what we actually do is that we do many things. Okay? There is a process of or evolution of how we move from something that is very raw into something that is a bit more designerly, simply because our neighbors, our designer neighbors, expect us to be quiet, expect us to be neat, to be tidy. So over time, we have to conform, right, for some reason. But nevertheless, when we introduce ourselves, we always say we are makers, but nobody in Singapore actually know what is a maker. They always think makers are, or maybe you are, or you make something with leather, or you are an artisan. So we'll say, oh, we are designers, we are makers, but we are also educators, because we actually create learning experiences for many people to enjoy making. So how we got started is that in about 5 years ago, the Singapore government decided that perhaps it is a very cool thing to have a public maker space. So they put up a call for a private operator to start what we used to be called a private-public partnership, to create a maker space for the public. But essentially, the idea back then was that there was a need to grow the hardware startup industry in Singapore. And one of the way they thought best was to have a prototyping lab that could support some of these nascent ideas. So somehow a few of us back then felt that this is a cool idea, and we actually came together to start a company. Previously, I was a school teacher. I taught for 15 years. I taught design and technology, which is why I'm a bit familiar with some of the things that the Fab Lab has, because I use them in my classes. So a few of us, basically crazy dudes, come together and start a company called One Maker Group, OMG. And in this case, we actually bid and we pitched, and we were selected, and we were given some funding. And this project actually is a 3-year project to basically create something that could support this startup industry. So as you can see, in the early days of our setup, we actually do a lot of hardcore maker stuff, right? So this is kind of like what people want to see. That's what is expected of us from the government. And of course, back then, 5 years ago, not many people actually understand what is this maker movement, what is all this, hacking and stuff. So there is a need to create public awareness. So we were given a lot of opportunities to create a lot of big shows in the public, so that people can actually enjoy, or at least appreciate the kind of work that we do, and they can join us as well. And the whole idea behind making is or why we want to do this in Singapore, is to advocate this idea of self-reliance, because perhaps the way we were brought up, we always depend on the government, and because we always happen to be in a one-party, system. So it seems that government seems to know everything, and the citizens, the people just sit back and let the government do whatever they want. But over time, that is not healthy. So there are people who actually say, sometimes the government do not have answer. And if there is a problem, the citizen should be the one taking charge and doing something to respond to whatever problems that we face, rather than waiting for the government to. So it's this whole idea of DIY, this whole idea of I can do it, I can like solve problems. I can do something without the government intervention. So that is kind of like the idea that we want to come in. And of course, while Singapore is ranked very highly in the educational ranking, but really it is a very stressful and sometimes is a very judgmental kind of environment. For example, if I want to make a PCB, I have to study 4 years in a electrical engineering school, in order to be qualified to handle electronics, But then again, is that really necessary in this day and age? So, and the knowledge is out there. What if anyone can get started without having to go through all these hoops? So that is the kind of promise that this whole maker movement, this FAB movement, is able to provide to us. And so that's why it kind of gave us a reason why we live every day to create this opportunity for our own people. But of course, like many places, sustainability is always the biggest struggle. We always have difficulty in terms of we have cash flow problems. We have issues where some projects didn't really turn up, and we have payroll to make. So this has always been the biggest struggle. And believe me or not, even without the influence of alcohol, I can tell you we were bleeding. We were losing so much money that we almost couldn't continue after the first 2 years. There was some restructuring. People, partners have to pull out. So there were a lot of challenges. There was a point in time where we were so depressed, and we would say, why do we want to do this? We are private enterprise, and shouldn't the government be doing all these things? So and sometimes it's really how to say had we know this is going to be, maybe we shouldn't start it. So that is how it was like back then in the first few years. Sometimes it is still today. We are still not out of the woods yet. So the situation we are in will be something like we are not exactly dying, but we are not exactly thriving as well. So we are not dead, we are not thriving. So that is a very sucky situation. But what to do? We just have to suck it up and live another day and hope the day will become better one day. So over time, things change in Singapore. Perhaps because we were doing a lot of things, or perhaps the government thinks that, hey, this thing is so cool. By 2016, this whole makerspace wave had reached fever pitch in Singapore. Basically, every other school in Singapore wants to build a makerspace for some reason. Okay, whether it is for show, it is it's good for the students. Everyone wants to build makerspace. So suddenly, makerspace making become mainstream. So it was very easy to so-called. In fact, there's no need to convince people that what we do is good. So how the government sees this is that they think that making is the cure for all sort of educational ills. One of the things that people have, one of the problems that we have in Singapore is, besides apathy, is that people are so fearful of taking up courses or taking up profession in the science and technology track. Everyone is so frightened to see a PCB. Everyone is so frightened to see an Arduino. If I want to frighten a group of girls, I just throw an Arduino board and the girls will scatter away. That I'm not kidding you. All right, everyone is so frightened because they perceive science and technology as something very complex, something very, it is not them. So it is really a struggle, and the government recognize it. So one of the things that we thought, which while working with government agencies as well as understanding parents' concern, we kind of redesign the way we do certain things. All right. So we are still true to our core as maker. Okay. We deal with technology, but we have to kind of redesign the experience to allow people from different ages, from the very young to the not so young, to the mature, to the pioneers, to the seniors, to have a very different experience, so that they do not see this as something very threatening. We also want to redesign the way people interact with materials. There are certain things that we have in Singapore which is considered trash. There are certain things which is considered, wow, this is awesome. What if we can kind of like mix it around and create alternative ways of interacting with it? So one of the projects that we do is creating this Lego pillar. You have seen Lego walls, but what about Lego pillars? And this idea came about because the school that we helped to build this pillar doesn't have a large wall, and they have a lot of kids who wants to enjoy, but they have many pillars. So in this case, we kind of like look at what they have and build accordingly, and suddenly it become an awesome idea. And when we pitch it to the local Lego distributor, and in this case, they love this idea, and so we have to kind of rely on them to give us some business. So essentially, what we are trying to do is find ways to and increase our product line, so to speak. At the same time, because of technology, a lot of teachers are very concerned. I'm not an engineer, I do not know coding, I do not know laser cutting and 3D printing. Can you help me? So sometimes we have to assure them that you don't have to start with all these fancy equipment first. Sometimes you start with the mindset first. You start with as a teacher, how do you prepare yourself? So don't be a teacher, be a student. Work together with your students. If this is your first time, just admit. It's okay. Just learn together. Be ready to come down from your high horse and just work with the students. So this kind of things that we want to inculcate and to help support the learning experience. And of course, most important thing is this human-to-human interaction. In Singapore, because we live in a very small place and it's very competitive, everyone is very egocentric. They are very self-centered. They only look after themselves. And because of this, human-to-human interaction becomes very important, especially when we talk about things like cooperation, things like teamwork. So in this case, we actually try to find ways of using these interaction as the objective for all our sessions. In other words, if I were to do a robotic class, my objective is not to teach them coding. In fact, my objective is to teach them how they can work together to solve a problem using robots. Okay. So yesterday in one of the workshops that I conducted using straws and motors, so there was a challenge that so far nobody solved it because everyone was doing on their own. The challenge is very simple. I have a bottle of water, and the idea is to build something that can topple this bottle of water. Sounds simple, but believe me, if you are going to tackle this problem on your own, you will fail. This problem can only be solved by two persons operating two different robots, in the opposite direction. That is the answer, But then again, see, the point I'm trying to say is that it is through cooperation that we can actually solve problem, and that is the key message, okay? Or at least that is the thing that differentiates us from many people who just want to deliver products or just services. So I kind of had some time during the bleak, depressing years or depressing moment last year to basically capture all these stories and I have the book with me. If you like to take a look, you can get it online, I believe, Amazon or yeah, there's a link to it. All right. So that's all. Right. So if later during lunch or during dinner, please offer some alcohol and more juice will flow up. Thank you very much.
Hello. Good morning, everyone. I'm from AKGC Fab Lab. I'm Professor Ashif Shah. This Fab Lab is running by AKGC Skills Foundation. It's a Section 8 company set up in public-private partnership mode with Government of India, Ministry of Skill. In India, there is a separate ministry for skill development and entrepreneurship, which is promoting this type of initiatives. And this Fab Lab is running in the premises of Ajay Kumar Garg Engineering College, which is one of the premier engineering college in Delhi. And Delhi is a capital of India, and in Delhi NCR region, this Fab Lab is working. Before I give you a brief description of various activities and the facilities of Fab Lab AKGC, let me just share with you that the scenario in India. See, post independence, India, there was a major challenge to give employment to youth. And for this reason, the government of India has started various programs to promote medium and small enterprises, industries. As a result, there was a many medium scale and small scale enterprises grown up, which has successfully given employment to many youth that time. It was good for decades, and after 2 decades, we realized, that the countries are open, and the businesses for running for the various other countries to come over and do the business in your country. As a result, the good products and highly quality and cost competitive products start coming to India, and which has created a scenario where these small and medium enterprises start, seeing the competition, and they were failed to match the competition with respect to quality and cost both. So in such a scenario, it was, this place where this AKGC Fab Lab exists is basically an industrial town which is adjacent to Delhi, national capital region. And thousands of medium and small scale industries are existing there. And when we walk over to these industrial areas, we see that every third industry is dying because of they are not able to produce good quality product, or they are failed to match the quality expectation of the customer or the consumer. As a result, the people and the youth, those who are employed in those industries, start losing their job. So there was two major things picked up by us. One is that how to improve, how to give them, the technology exposure to these dying industries, especially the medium and small scale industries. And second thing is how to develop your youth so that they can actually handle that high quality things. So with these two objectives, this AKGC Skill Foundation start working, and we set up this AKGC Fab Lab at AKGC campus. Sorry, one second. Yeah. Okay. So while we set up this Fab Lab, this is basically supported by top industry leaders, technology leaders, and on the one corner we were having the academic institution, which is represented by AKGC and Ministry of Skill Development, the Government of India. These are the 12 industry partners who are regularly supporting the working and the various technologies available at AKGC's Fab Lab. We are at Delhi, as I already told you. Our focus for this Fab Lab is giving training in high technology domain, taking up applied research. So a lot of SMEs are, they are sitting with a lot of challenges. And these challenges they pose to AKGC Fab Lab team, and we take up as a applied research project, and we work and we try to give them various solutions which improve their quality, and which make them sustainable or which make them competitive in the market. We also develop various prototypes and we support various innovation activities. AKGC Fab Labs in last 3 years, we are running a Fab Academy program. This is the third batch we are running currently, and we have 6 students, enrolled in AKGC Fab Academy this year. If I talk about various infrastructure and facilities available at AKGC Fab Lab, it is divided into these 9 domains broadly, which includes industrial robotics, virtual instrumentation, automation technology, pneumatic technology, advanced manufacturing, welding technology, prototyping, CAD/CAM, it's a design center, and drive and control setup. This AKGC Fab Lab is basically the development of Fab Lab was incremental. Year after year, we keep adding new facilities. So we are not actually situated in a one single hall or something like this. Rather, we started with a small space. So there was a one room given to us, and then as we grown further, so another year we added, the new rooms, and that is how in last 8 to 9 years we could add up these 8 to 9 facilities here. We are also supporting, as I told you, that this is the main focus of this Fab Lab is to support small and medium enterprises. And initially, this Fab Lab was working with individual industries. So whosoever is having a problem, they can come to AKGC Fab Lab, give their problem, and then we start working and we usually give them a solution. Later on, we realized that like this, we cannot serve to masses. So, and the people, because of their commercial interests, they do not share whatever the solution we have given to them. They do not share that with others. So what AKGC Fab Lab has done, we have signed various MOUs with different industrial associations, so that we are accepting problems only through industrial association. So when we give solution to one industrial association, that solution is passed to all the various industries, those who are working in the similar domain. So like this, we have actually multiplied our effect on industry by giving solution to one problem. We were helping many industries, those who are partner. So that's the reason we have signed MOUs with different organizations, CII, GMA, AIA, and all. Now, while we are working for industrial solutions, it is not possible to have all related knowledge, domain knowledge available with us. Just to, because we need to give industry level solutions, we have collaborated with various knowledge bodies, which are functional in India or globally. That is International Society of Automation, Fuel Power Society of India, American Welding Society, and all. So these societies and these knowledge bodies, they help us whenever we come across any problem, and it is not possible for us to locally solve that challenge. So we go to these knowledge bodies, take their expertise, and try to build up an industry-grade solution using that. This is a small, look, my Fab Lab look like. It is divided into three different, portions. One is dedicated for electronics, other one is dedicated to mechanical setup, and then one area is a 3D printing area. we are having like any other Fab Lab, so we have all different equipments, whatever is required or whatever is listed or recommended any Fab Lab to have. So we are also having all that. Quickly, I will just give you a detail about some of the activities which are conducted by us. We are regularly conducting various workshops on embedded and IoT. As I said, that our focus is actually twofold. One is to support the small and medium enterprises exist in that area. The second is making the youth, making them employable or making them suitable to deal with these high technology domains. So there are two Government of India initiatives called Make in India and Skill India, and AKGC Skill Foundation is supporting both the Government of India initiatives through their activities. And for supporting these two initiatives, we conduct various workshops and camps. So we organize innovation camp for young ones. We organize a training program for engineers on digital fabrication. We also conducted a one-day drone workshop. There is a new program which recently we started, and I want to emphasize on this. We have seen largely the declining trend in engineering education by the youth. And the reason is that in India, the engineering program is more theoretical. The idea is to make them a knowledge, worker for the industry. But with respect to the time and the change requirement from the industry side, they are failed to meet the industry requirement, because of which there is a lot of unemployment happened after when they passed out, engineering. And the reason is their lack of, interest in doing things by their own hand or learning a practical, aspect of engineering. Just to generate the interest of students in engineering, we started for first year student, we started an engineering exploration program, which we conducted for 900 students, 900 engineering students in the year 2018, and which was quite successful. The engineering exploration program, it was a 5 days program where in a structured way, we organize 5 different workshops just to motivate them and give them a thrill of engineering, so that their dying interest in engineering can be revived and they can start again seeing engineering as a thrilling career for them. So this was successfully done by us for around 800 to 900 students this last year. And this year, I'm just looking forward if other Fab Labs, international Fab Labs from different geographies, if they can come forward and join me for conducting this by making it a true international program and conducting it for engineers in India. This is some pictures. We conducted a drone workshop for under engineering exploration program. We conducted a drone workshop for engineers. Quick, the glance over my facilities, so that which will give you, kind of overview what these technologies are. So we have a robotics center. This is a fantastic center we are having. I'm having around 12 industrial robots of different capacities, which are actually performing various engineering applications, including robotic welding, material handling, and so on. It's another shop. We call it Advanced Welding Lab. We have a robotic milling facility where we actually help various architects and artisans to develop various sculptures using different materials. And then we are having, this is a cold metal transfer setup, which is, there is a new concept in industry now, weld arc additive manufacturing, WAN. So this is, through this setup, we can create metallic 3D printing objects. This is a welding technology center. The various welding related technologies are available here for prototyping, for learning, training, and doing a proof of concept for the industry. So a lot of local industries, those who want to improve their processes, they come to learn these technologies, they come for proof of concepting, they come for prototyping purpose. We also have a metal cutting setup, NDT center, and we have a huge machining center where we train people on CNC turning, milling, and all, and also we use this facility to develop various prototypes for the industry. Metrology section and automation, mechatronics section, fluid, hydraulics and pneumatic section, and virtual instrumentation section, design center, and this is a low-cost automation development center. So especially when we researched and we came to know that the most important thing for SMEs, which is preventing them to adopting the automation solutions for improving their process, is the cost. So we start developing the low-cost version of various standard automation products which are available in the market, so that these low-cost automation on the solutions can be immediately accepted by these SMEs for improving their processes. We were awarded, and recently, just few months back, we were awarded as Excellence and Innovation in Robotics Education Award by All India Council of Robotic Education. We were awarded for our student projects were awarded, and different projects were awarded at various national and international competitions. So I have a large team available with me where different experts are working and developing a various industry grade solutions. Thank you very much.
Over the past decade, deforestation has been a global phenomenon. A statistic conducted by United Nations Sustainable Development Goals shows that around 30 million hectares of forest are deforested, that can lead to the certification of 3.6 billion hectares. If degradation is persistent, in fact, World Wildlife understands that we're losing 18.7 million acres of forest annually, equivalent to 27,000 fields every year. This impact people's livelihoods and presents a wide range of climate and environment.
fishing places, we have food, our air, our water, even our land. So without this, everything we need to survive will not provide any value anymore. So that near the beginning of security, without the animals in the forest, without the insects pollinate the plants, we can get our example, our fruits, our rice, without the forest protecting the soils in our watersheds, we will have water. So these things are very basic for us.
In the Philippines, alone around 46 to 58,000 square miles of forest are lost each year. This has been alarming since as of 2010. 57% of the Philippines forests are now and were already turned into grasslands and deserts. Stated in the United Nations Food and Agricultural Organization, we found out that within 11 years from 1999 to 2010, the Philippines lost over 54,000 hectares of trees annually, and we need an urgent solution to this industrial level of forest destruction.
Good morning, everyone. I am Jay Gahudo from the Philippines. I am a resident maker of FabLab Mindanao, and this is our research, which is one of the product of FabLab Mindanao. And I am taking a course of BS Electronic and Computer Technology in MSU IIT. And I'm here to tell you about a story of our beloved department, Computer of Applications, and of course the FabLab Mindanao who helped us molded our research. And we all know the problem like deforestation. I know that thing when I was in grade 3. I am fully aware about that thing. And we all know that the Earth is now sustaining an enormous 7 billion human species and counting. Due to this number, the global needs and wants increases, causing the clearing of our remaining forests for new settlements, urbanization, agricultural expansion, livestock raising, extension of infrastructure, mining, illegal logging, and paper industries. And other researchers are also looking for the solution of those things I mentioned. And in our part, as one of the researchers in MSU IIT, is to find a solution in the global goal SDG number 15, the life on land, and also that also ripples the effect on the SDG number 13, the climate action. In this table is a Nash equilibrium. The researchers set the deforestation and reforestation as both opponents, because as observed in nature, those two opponents uses the same way of reforestation, the same way of technique. The deforestation uses technology and of traditional ways, so as the reforestation uses a bit of the technology and more likely to be traditional. In fact, deforestation nowadays uses technology to do faster job, while reforestation is instilled in manual traditional tree planting system, resulting to a very slow progress and cannot fight back the industrial scale deforestation. And here, our researchers like to decide to apply technology on reforestation, which is like, if we do our if we put technology on reforestation to fight technology on reforestation, both are fairly fast. While if actually the right now in this world, like deforestation uses technology and reforestation is still in a traditional method, results to reforestation rate is low if deforestation uses technology because it takes like a minute for us to plant a single tree. And if the deforestation is traditional, like we're using it in primitive way, just like in Stone Age, the deforestation rate is low if we are using a technology, but I don't think it existed here, maybe in a parallel universe. And if both are using traditional, like way back before we industrial revolution, both are fair. They are both slow. So this idea, we're not bringing a knife to a gunfight. In our country, the Philippines, or even in other tropical countries, if you notice that plants are growing randomly in some places or even in on a severe environment. Yeah, just like that. It's actually like we call it. It's like a native cherry. It's a tree, but it's growing randomly. Yeah, even in the severe places, in the streets, yeah, even in that area. And of course, it's not our grandmother who planted a tree. It's not a human being who planted a tree. So we are actually thinking, who did that? And basically, it's nature's way of finding a life, or let me say, nature's way of reforestation. But it is not a magic of those trees are there. There must be an explanation, because actually, who planted that tree are not humans. We just observe that it's not actually us, but who would ever do that? It is the birds who has no toilet etiquette to poop everywhere. They disperse seeds everywhere. And that is our inspiration. We are actually inspired by the Asian glossy starling, Galansiang in our local term, Cebuano, a fruit-eating bird that helps growing plants by dispersing seeds from its food. And these birds actually known as a pest by some farmers because not because they eat the crops, but because they poop in the middle of the rice field. And a few weeks or months later, there's a huge tree growing. There's an invasive tree in the middle of the rice field. So those birds are our inspiration. So we came up with an idea to mimic the nature's way of reforestation into a mechanical robotic way. And we called it the Project Galansiang, which is our research. A fixed-wing unmanned aerial vehicle using real-time image recognition for sustainable reforestation. The plane is like, we bought it from Singapore and the plane already existed. We didn't invent the plane because Wright brothers did it. What we did here is to modify. There are lots of usage in UAV technologies, but there are only around 3 in this world right now using it for reforestation. The thing that I know is they did it in Myanmar by biocarbon engineering. And now, in this time, the innovation here is like, there's no initial mapping needed. All you have to do is like, you have to fly the plane and let the planting system begin. Because we program it with artificial intelligence to recognize the data below. If the plane flies over the deforested area, the image sensor and the LiDAR will analyze everything and plant the right trees. The research is like a highly modified fixed-wing frame of Skywalker E2000 that carries around 9,000 to 10,000 germinating seeds to be dropped in the damaged area. Yeah, that's the simulation test. It's fly-by-wire. And the parts are divided into two. The drone itself, which we actually like just buy and modify consists of a flight controller, a GPS with compass, telemetry transceiver, radio receiver, power module, and LiPo battery, and of course, an airspeed sensor. Now, in the part that we made actually is the SIG carrier. It consists of the Arduino M0 Pro for processing and controlling, and a vision sensor, a camera, and a LiDAR, which we program to recognize things, to recognize the area, just like mapping and scanning, but live. Did it with the system. And the output will be like the digital slim servo. It's like, oh wait, I'm sorry. It's like this data this sensor fetch every data and then read by the Arduino and then decoded by the Arduino and then the digital scheme server will execute the planting sequence. Now this is like the prototype that we made and we use a PET bottle from Pepsi, but I'm not endorsing Pepsi here. Yeah, but actually it's not 3D printed, but this is an old photo that I've got in my laptop. And this is the Arduino and the sensor are right here. So the design is like a blasting missile to be more aerodynamic, and this is the last prototype that we made because we undergo a lot of prototypes. And FabLab helped us to create this thing. This is the final photo of the prototype, and the other prototype as well we created in FabLab. And our final version is like we use a PCV tube and yeah, the battle, but it's 3D printed now, as what I've said. We laser cut the door and did a testing. Even the door takes like around 3 prototypes. And here is the build and test video we have. That's the first design of our prototype, but it doesn't go well. And now we finally made the last one. That's the collaboration. So when everything is like all fine, like the plane is working and the system also is working, we decided to do a fly-by-wire simulation test. So we put something in that area for deforested subject so that the sensor can detect it as deforested because of the soil. And a reforest subject, we put something, a white blanket, because if we are not putting a blanket, the sensor will detect a deforested since it is a ground. So if white doesn't exist in forest, so we just put it here above the canopy. That's the fly-by-wire simulation test. You can see it passes in deforested area, it's detecting, and when it passes in the forest, it stops because it recognizes it as forest. And then the result is really surprised us because we didn't expect that there are average of 77 seedlings in 7 seconds, in less than 7 seconds. And this is the conclusion video that I'll be presenting to you. The CAP of the Philippines allowed us to use their airport. This was like before the flight test, before it will crash. But it's not, it didn't crash. This will be the result. Yeah, that's it. That surprises us as well. I'm so sorry I don't have the flight video because I made this one in Manila and in here, and I forgot the SD card that consists of all the flight videos. And we would like also to thank the following: our university, our college, and of course, FabLab Mindanao. Thank you so much.
Okay, we are just in time. Thank you for all the presentation and reviews. We're going to have 30 minutes break, and after that, we're going to have a topic talk from OpenDesk and Fabricality. Thank you.
Hello, friends. Please return your interpreters when the conference is finished. Please.
Really nice.
You take all the videos and you make videos. Very nice. Thank you.
Hi, how are you?
Did you take the class economy class?
Oh my God, yes I did. Yes, I was here till 1 a.m. You know, I'll sleep when I'm dead. Plenty of time to do that. Too much to learn, too much to hear. Everybody's so inspiring. I want to go do something important now. I can't wait to graduate and come up with my own project.
Very soon.
Yeah, I've never been to Vietnam. I go to Thailand all the time. I mean, certainly I want to do something in Thailand. I'm definitely going to come visit you. Because I think that this idea of creating your own fabrication materials, I don't know, that's the things that makes me nervous a little bit. And it scares me, this is anything else. Is people technology and machine fetishism that is a part of this field. It's another, they're just back and forth, right? So soon something's going to be I mean, yeah. It's more always and things are spiritual, which is time and so sufficiency, sufficiency. One person can see and listen. How was
얘를 올릴 수 있고 그리고 바닥을 쳐서 여기는 들리면 이런 밀고 쳐서 끌고 하면은 이건 가능하지 않은 목표가 계속 들리고 있어요.
네,
이상하게 간식을 먹고 오면 더 추워지네. 술 먹었어.
거기 음향만 들려요.
So you find that so rejection on society. So what is the choice?
배경음악이 들으니까 생각나네.
So I have answered that now. So now,
아니야. 그건 저거 할 수가 있어. 여기 타이틀하고 저것도 많아. 야, 진짜 지금 그거 싼 때문에 우드 시트도 거의 같은 데서 좀더 돌아줄 수 있을 것 같아.
so
근데 이건 거야. 타이거 어떻게 보면 큰 많대. 그래서 충분히 아예 타이로 해야 되나? 신청해서 그냥 때리는 여기서만 쓰는 거지. 그래서 안 돼서.
Yeah, I've got yours.
이렇게 돌아가지 않나? 어디서 보이는 아이디어 없나? 이렇게 주셨구나. 오즈모? 오즈모 아니야? 오즈모는 일본인데.
This is class.
왜 주변 꽂아서 있는 거야? 노래 안 들어가지. Thank you.
Great, thanks.
There's a guy.
I guess that's fine. That's just what you have to
Yeah. Don't long.
yeah, I agree with you. Because they were too low. Go for the yeah. Actually, this is what it is there. I actually hired people like that. I am like speaking out there. That's the thing.
Let's go to the I.
And
You know, if I go a bit longer, do you want to like, because I have a lot of slides, but I normally go quite fast because I like to show lots of things.
The video, he has only 20 minutes.
Okay, so if you think I need to speed up, just tell me.
Okay.
I don't mind. Okay. They're like this, like.
Or you want me to do like this or this?
Yeah, something like that. Yeah, like that.
Like this?
Or like.
웬디 영상? 여자분 영상? 웬디랑 뒤에 사람 두 명. 있어요? 받아왔어요. 아, 네네, 잘하셨어요. 웬디 영상이 있다는 뉴스 어떻게 아세요? 봤었어요? 아니면 넘겨가지고 틀어주면 돼요. 그거 맞죠? 맞아요. 웰링턴. 아니요. 지금 추천자 하고 있습니다. 세계 태국으로 위해서 마지막 세계 태국으로 여기서 거기서 축사 영문 세개 틀고 여기 축사에서 들어요.
Hi everyone, I'm Hiro Tanaka. Hi everyone, I'm Hiro Tanaka, the founder of FabLab in Japan. Congratulations to have Fab5 in Seoul. I'm in UK now to attend the international conferences. So I'm so sorry not to be there with you guys, but I strongly believe that you have very exciting and fruitful conference in school. See you again, and yes, hope you enjoy. Bye.
Hi, I'm Gianluca from Madrid, and I want to congratulate Seoul Innovation Fab Lab for hosting the 5th ASEAN Network Conference. Have a nice time, guys.
Hi, this is Ferdi from Germany. Right now I'm in Portugal teaching digital fabrication in a small phablet in Montemollo. Congratulations to Seoul Innovation Phablet for hosting the 5th Phablet Asia Network Conference. Now this is the part where I'm going to blame myself. Suninchi Irokaule, Leitze Putoya de Vehu. I didn't say anything bad. Have a great conference. Hope to see you in Egypt. Bye bye.
Hi everyone.
Done for the videos? Okay, so how many of you have tried open source of OpenDesk? I know Campus D, they have OpenDesk, like they made all the furnitures with OpenDesk sources. Yes, we have, and FabLab Jeju, FabLab in Jeju Island, they also have all the furnitures with OpenDesk. And we also tried a lot of different kind of furnitures from OpenDesk. So this time, we have different themes every day. So first day was about making sustainability. What was the second day? Everybody remembers? What was the second day of the next,
and this is a laser pointer. Nice, okay.
Pardon? No? So the third day is about making productive lifestyle. So about the theme, we are going to invite Johnny from OpenDesk for his speech.
Can everyone hear me? Yeah. Great. Well, first of all, do I need to hold this? Yeah. Okay. First of all, thank you very much for inviting me over from London. It's fantastic to be here, my first time in South Korea. And yeah, it's a real pleasure to be able to tell you a little bit about the story of OpenDesk. I thought I would tell you a whole story about how we started it, my background, and then the kind of things that we're working on now and things that we'll work on in the future. I also would like to say that if anyone has any questions, you can just jump in at any point. I really like it if people do ask questions now or afterwards. And I have quite a lot of slides, so I'll try and go quickly, but I might need to be told to speed up later. So really my background is in architecture. And as some people may know, architecture projects take a long time. This building I worked on for 4 years from the beginning until the end, so a really slow process. A great building to work on, great teams, but I learned that actually sort of the innovation around construction and building and making is, it needs to speed up, and there's a lot of things that we can improve on. And at the same time, I was involved in another project that you might know called WikiHouse. This is a kind of sister project to OpenDesk. So this is looking at the scale of a house, whereas we're focused on the furniture scale, and it uses a lot of similar overlapping ideas and thinking about on-demand local fabrication. So I won't go into this now, but just to say that these are two projects that we started at the same time, maybe 4 years, 5 years ago, and we've been working on them side by side. So at the same time, we also, in London, we set up some co-working spaces, and these were really our kind of prototyping labs for both the WikiHouse. We built some small meeting spaces like miniature WikiHouses, and also, of course, the furniture. So we actually prototyped everything in a live environment with real people, getting feedback, making the furniture ourselves, learning as we actually, as we did it. So learning through doing. And I guess really what excited me as an architect is getting involved in the making process. And of course, we all know a lot about these things, but when I go and talk to other people outside of these kind of environments, a lot of people, it's quite interesting to find out that lots of people really don't realize that you can actually still go into a workshop and make prototypes, not in 4 years, not in 4 days, but in 4 hours or even 4 minutes. So this idea that we can work and build things and get feedback and iterate and learn, it's actually, to us, I think it's probably quite common, but to a lot of people, it's not common. And I think that's something that I learned over the years, that this is very powerful. And of course, as technologies mature, the costs come down and the access increases. So we find more and more people having more and more access to technologies. And of course, there's a lot of amazing tools, both software and hardware, that are emerging all the time that you're probably very familiar with. We actually focused on CNC milling because it's we thought it was one of the most adopted and available technologies. So it's actually an old technology that we can find in workshops all around the world. And that's actually a deliberate choice on our side to focus on something which is already quite mature and sort of established. Why did we get excited about this in the first place? Well, it's really about the story of the 20th century model of production, where things get made in one location and then they get shipped many, many thousands of miles around the world. And, this is a model that we're all familiar with, but of course, with digital tools for designing and making, we can actually start to disrupt this. We can start to make things anywhere, and we can start to really think about supply chains that are a lot more local, more sustainable, more human scaled, and more social. And this is really what kind of inspired the thinking behind OpenDesk and WikiHouse and projects like this. Of course, it's big global flows. We're all familiar with that. But actually, we're talking about something at this scale, which is really hard to see because it's a whole different scale. It's the scale of a city. If you look at London, we're actually talking about hyperlocal supply chains, hyperlocal production. This is different workshops that we work with in London and how close they are to the actual people that are using the furniture. So we're really talking about things moving just across from one side of the city to the other. So really, the OpenDesk started with a question. We didn't actually start thinking we're going to build a company or do anything like this. We started as a couple of architects interested in digital fabrication, thinking, right, all the people that we know are very good designers digitally. They're digitally native. There's actually many hundreds of people that have tools in fab labs, in workshops all around the world, but they're not really connected necessarily. How could we actually build something which connects these people and provides a platform or a framework to be able to say, right, we can share things between ourselves and we can make things locally through this network, so we can actually draw on the power of the network. And really that's the thinking, and things like Creative Commons. How do we actually share things and sort of be permissive, but also control the design rights to things? I'll mention that a bit later. And of course, the real excitement is that we can think of very big things being actually about many, many small things. So, it's very powerful to have a distributed factory. It's very powerful to have a whole network that can produce many things, but in very small pieces, rather than one centralized element. So the kind of long tail, this idea that you can download the plans to a CNC machine like the Blackfoot, you can build it in your garage, you can plug in your laptop and you can start making WikiHouses, OpenDesks, or any products, or all the kind of fantastic products that we see in Fab Labs. This to us is really powerful and really exciting. So how did OpenDesk start? It actually started by us being approached by a company in London who wanted us to design their office, and they asked us to design not just the office environment, but also the furniture. And we actually said to them, you know, it's a really bad idea to ask architects to design furniture because architects are very slow, they're very expensive. There's lots of great furniture already in the world. Like, why ask architects to design furniture? But really, what was fantastic is that this company was a digital design agency, and they said, well, we think that there's value if you design the furniture for us, specifically for our workspace, and in a way that we can have it made locally near to our office. You know, we want to be part of the process. We want to actually be part of the design process of not just the environment of our office, but also the furniture, the things that we're going to use. So we actually got really challenged by this client, and we really credit them for helping to push us to think about this. I think you're all probably very familiar with CNC machines, so it's basically super simple designs that are deliberately built from very simple parts that we can sort of piece together, slot together, clip together in the easiest way. So we're actually trying to design things to be fun to build. So the building process itself is actually part of the experience. So you know, that's a big consideration. Of course, I think maybe people here have built OpenDesk. There's probably a lot of improvements that we can make. So any feedback is welcome. And we're always iterating, we're always changing, we're always looking to improve things. So yeah, from the first desk, we then actually, so we were working in a co-working space, and we had a lot of people there who would sort of leave this co-working space to start their own office, and they would ask us, can we have this furniture, can we have these desks in our space? So we actually started in a kind of accidental way, if you like, the company, because we realized, well, we have a lot of people asking for this furniture, we have some designs, we know some workshops in London, we should build a website which connects all these things. So it was actually a very sort of organic process that led us to set this up. So what is OpenDesk is actually, as you probably know, a library of designs online, which is growing, and then a whole network of workshops that you can search for with a postcode. Basically, that means you can have whichever design you want made in whichever workshop you want, in theory. We then, after we built the initial website, we asked the question, sort of, we had one design, just one desk. And we said, right, now what would everybody like to have as the next design? So we asked the kind of crowdsourcing question, and the response was, we would like a desk which we can adjust the height of. And really then, once we'd asked this question, we realized, well, there's designers everywhere who have designs kind of sitting on their hard drives, on their laptops. Why don't we actually ask everybody to share those designs if they want to? So we started to get a lot of designs, and I mean a lot. Like, we haven't been able to keep up with this. We might need to appeal for help, because we have so many designs sent to us. And this was a learning point for us. It's actually really quite, it takes quite a lot of time to prototype and test and get everything ready to make something which is robust and we can share with the whole network, because we don't really want to share things unless we're really confident that it's going to work. So this is an area that we really need to improve on. How do we actually build out a whole library of new designs? We have maybe 50 designs at the moment. We have probably 500 waiting, and we're a very small team, so we actually have this bottleneck where we can't release things fast enough. So just to show you some of the things, we got some nice recognition. We have people saying, yeah, we really like the designs, but I think mostly like this concept. We like this concept that now we can take high quality products and make them through a network as local as possible. And what basically, yeah, this has led us to having a whole range of products growing. But then there's the other side. So how do we actually initially find out about all the different workshops? Of course, when it comes to Fab Labs, we can sort of look up through the Fab Lab network, and people contact us. it's quite easy to find out where Fab Labs are, but actually other workshops, so smaller commercial workshops, a lot of people are based in London, for example, under a railway arch or in a very small space that they don't have a website. They're actually quite hidden. So we did a lot of work, and we built a website, as a sort of second website called Fab Hub, where anybody who is a maker with digital tools can go there and they can join, and it's free, and they can list themselves as a maker. And that was really for us to see, like, how many people are we talking about, and in each city, how can we uncover all these fantastic projects, makers, the capacity, how can we kind of bring this capacity to life, and then make this open so people can find these people, and then we can also start to talk to them about perhaps working with us. So this is just to show you, and these numbers are changing all the time, so it's probably not very accurate right now. We have a couple of hundred workshops that we work with at the moment, and then maybe another few hundred that are waiting to join. I've spoken to some people about that today. Again, we're a very small team, so it takes us some time to work with every workshop, because we really want to make sure that people understand the kind of setup and the quality and things like that. So it's something, again, for us to improve on a lot, that we might need to ask for help on this front too. How do we actually get more people to join faster? So just to show you some of these, the actual people behind the making. This is a Fab Lab in London, in East London, in Hackney. We used to be based next door to these guys, called Machines Room. Really great space. They run all different workshops for schools, learning, and at the same time, they do some commercial projects to kind of help fund the running of the space. So they make open desks on the kind of downtime between their actual learning programs. Then if we go to Brooklyn in New York, a company called Factory NYC. And then at the small end of the scale, it's a maker called Kyle in San Diego in the USA, who he started working from his garage. He was a woodworker. It was his hobby, and he really wanted to be able to do to sort of change career and make this his main job. And I think partly with the help of OpenDesk, but with other projects, he's managed to do that, and he's managed to build out a bigger workshop. So these kind of stories really inspire us. People who are making things because they love making, and they're innovating, and they're able to, do that on their own terms. Then if we go to Mexico City, this is Enrique's workshop, family-run workshop. And then in London again, this is the workshop nearest to our office now, which is called Wilder Creative. And then a couple of journeys to show you. So some of the first projects that we worked on after this initial idea, one of them was the offices for Greenpeace. So, big company, big organization. Their London office, also a really hard company to work with, because they're so, they really care about everything, as you can imagine. They really want to know, like, where does this material come from? Who's making the products? Are they fairly paid? Are they well treated? And because it's Greenpeace, they wanted to also visit the workshop. And they also wanted to visit in the lunch break, and they wanted to visit on their bikes, because they don't like to drive cars or anything. So we had a big challenge here, like, how do we find someone really, really close by that they can visit? Luckily, because it's London, we work with quite a lot of workshops. So there was somebody, there's a workshop called Wooden Horse, and the Greenpeace office is down here on the left. and the workshop on the right, and it's like 10 minutes away. So just to show you a kind of a local journey in London, just to say that this is possible. And then again, another one in New York. This is the Etsy offices. Associated Fabrication, another workshop in Brooklyn. And their office is right opposite Manhattan. And so this is like 25 minutes away in a major city. So really just to say, yeah, these workshops are everywhere, and it's really possible to work at this scale. And it's a scale of working from very small objects right up to full interiors. Because we're architects, we're kind of excited about working on all different scales. We're now focusing more on the furniture, but at some points we were really looking at the whole environment, the whole interior environment. And this is a company called Kano, which makes open source computers so that children can build computers and learn to code. In this case, we actually work with them to customize one of our original desks to make it into kind of a parts store for their computer. So this is also some of the work that we do to sort of take a design and adapt it. And then a project called Here East, which is the Olympic Park in London has now become many different venues, including a kind of innovation park for startup companies. And we work with them. All their furniture was made like 5 minutes away. So just to show you, like from very small startups up to really big companies. And then, of course, what's really exciting for us is this idea that with digital fabrication made on demand locally, designers can really start to think about products in a different way. They can start to think about products not being like a fixed object, but being something which can change and version, and it's something which is fluid. So we can actually have one design which becomes other things. I think that's probably familiar to all of us, but actually when we speak to product designers who are not used to this, to them it's actually a really alien concept. Because this is more like the world of software design, where it's quite common to have a project shared on a platform like GitHub, which is multi-authored, attributed, like a family tree, which shows who are all the authors on this project, and how have they contributed, and how are we building on the back of other people's work, but still always making sure we attribute the original author. This is actually not that common, I think, in product design and physical design. Just a basic example of that is a designer, an architect called Dennis in Sao Paulo in Brazil, who shared this chair. This is one of the first products that we prototyped and made from a kind of outside designer. And Dennis chose to share his design. He chose a Creative Commons license, which means whenever it's downloaded and made for personal use in a Fab Lab, he's very happy for that to happen. He really actively encourages this, but whenever it's made commercially and there's a company paying for it, he would like to also receive like a small amount. And this is basically how the model works. So when it's made in a Fab Lab or DIY, it's free. When it's made for a company, he manages to get small payment. But also because he shared his files, it means that other people can take it and do a different version. So this is Cecile, who's based in Paris, who's downloaded his chair and made it into a rocking chair. And of course, what we're really excited about is this is taking hardware into the software approach. We can actually start to see many outcomes from one original starting point. And of course, it also throws up many questions, like who owns this new chair? Who's responsible for it? Who gets paid when this gets made? And these are all questions that we don't necessarily have the answers for, or at least we don't have the correct answer. I don't think there is a correct answer. I think it's actually a journey, and these are actually questions that we're excited to start to think about. Of course, with on-demand production, we can personalize things. We can integrate other products like electronics and we can make modular parts. So it really starts to make hardware something that is more playful. It's something that can be upgraded. It's no longer a fixed object. And so, yeah, just to sort of say, well, what is it? Why do we think this is? Why do people think that this is interesting? Also, because we're talking about going directly from the workshop to the customer or the client or the user. So we can cut out things like the shipping, the warehousing, retail, all those costs that kind of add up, and we can make things quicker. We can actually make things in a couple of weeks, and if you were ordering a lot of furniture for an office in London, it would probably be maybe 6 or 7 weeks, even longer. If anyone hasn't seen the OpenDesk website, just to show you, you know, basically, yes, you can buy things there, but it's not like buying something on Amazon. It's actually saying, I would like to ask for a quote from a workshop. I would like a workshop to provide a quote for me in my city, in my local currency, in a price which is relevant to that geography. And the way it works is actually to take the cost of the manufacturing and then to work out some fees which are based on that, and then the price to the client is generated in this way. And so when you look at that compared to traditional manufacturing, what you see is, of course, we can't compete with, you know, some people that, like, let's say IKEA or some very, very big companies. Of course, they're able to make things incredibly cheaply because they're making huge volumes. We're not trying to compete with that, and I don't think we should compete with that. But what's interesting is when we look at actually who benefits in this model, it's actually quite different. So the traditional model on the left, the manufacturer is maybe 20%, and the retailer is actually taking a huge amount. And in our model, we like to think that this reflects maybe more fairly on the actual contribution. So we think the manufacturers should actually be getting a much fairer price. And then, of course, how does this work? Well, it's really complicated. Actually, we're building the sort of technology under the hood. So the platform that we're building is about how do we manage many, many digital files and designs? How do we present this online, and how do we link this up in real time to a workshop in wherever it is in the world? So it's actually, yeah, quite complicated, quite a simple idea, but underneath it it's very complex. That's also why it's taking us some time to build. So if anyone has questions about this, I can talk about it more later because it's quite detailed. Of course, everything's built in 3D parametrically, so we can actually scale. You're probably familiar with this as well, but we can say, okay, we would like this desk to be longer. We can actually just scale it in the model, and then we can export from the model straight to the production files. And that means we can change the dimensions of things, but it also means that we can export a design to very different material tolerances. So we can actually work with the exact material that you have in the Fab Lab or in the workshop. And why is that exciting? Well, we think that's exciting because it also starts to open up new possibilities for materials. So this is where I start to think about the near future. Of course, we're working with sheet materials like plywood because it's universally available. We can get that everywhere. But what we find is that, of course, not all cities have forests next door, right? So even if we're making things locally in the city, we're having to ship in the materials. But one thing that all cities definitely do have is a lot of waste. And there are some fantastic companies who are starting to think about this problem. Probably in South Korea, there's people thinking about this in a different way. These are just 3 companies in the UK. We're really excited about this idea that there are going to be people thinking about this all over the world and coming with their own solutions. How to take waste, post-consumer waste, and turn it into usable materials. So On the left, we have waste fabric, like from jeans, from t-shirts, from clothing. In the middle, we have waste plastics from things like bottles, yogurt pots, all the things that we use. And on the right, we have wool, waste wool. And these companies, they're all producing sheet materials from this waste. And the great thing about this is it can all be used by the same workshops that are currently building OpenDesk products. So basically, any Fab Lab with a CNC machine can start to use these materials. Of course, what's also great about these materials are not only are they recycled, their waste being turned into usable material, but they can then be returned to endlessly in a kind of closed loop. So we're talking about a circular economy approach where we don't have to put any materials in the ground into landfill. And really, I think that's where we should all be trying to get to, and it's something that we're really excited about. And at the moment, I think the barrier is the cost, because actually the cost of a recycled plastic sheet is still higher than buying a plywood sheet or something. But I think that's changing and the costs come down. And then one project that we're looking at, which is not live yet, is trying to say every time an OpenDesk product is, every OpenDesk design has a kind of digital file, so it has an ID, like a digital ID. But we're not thinking about that like the code that you have in a storeroom. We're thinking of it more like a passport number. And what that actually allows us to do is to take any piece of furniture and say, we know what this piece of furniture is, where it was made. So we can say, right, this chair or this desk, it was designed by this person, it was downloaded in this location, it was made by this workshop, and it was using these materials, and it's this version of the design. So we can actually capture a whole lot of information about any product, and we can host that online like a sort of a digital passport and say, right, you know, your desk or your chair, it has a story, it has a history, and then if something breaks, something gets damaged, we can actually, we know so much about this product, we can repair it, we can replace just the piece which got broken. So we can actually add value to products, to physical products, by giving them a kind of digital life as well. And then, yeah, just to end with a small project that we recently did. So we're talking about digital design, digital manufacturing. Of course, we don't have, as I said, we don't have warehouses, we don't have showrooms, because everything's made on demand locally. So how do we actually show people the products? Because people want to see what they're going to buy or make. And of course, now we're able to use AR, we're able to actually visualize things in place, because everything's built in 3D, we can actually start to superimpose. And so we did a little test with that, and this is just to show you how that runs. Unfortunately, at the moment, it's only running on Apple, but we're working on making it more available. But yeah, this idea that you can basically try things out virtually, and the idea would be to go from here to be able to scale it. So if maybe you want a desk which is a bit longer, you can actually do that in the app, and then connect to the nearest workshop because it knows where you are geographically, and then get the quote, and then get it made. So that's what we've been working on. Thank you very much.
Thank you very much for the really nice speech. Now we're going to have Fiori from Fabric Academy. So Fabric Academy, I'm really interested in Fabric Academy. So I especially invited Fiori, and I actually,
Claudia.
Yeah, Claudia. Yes. I mean, 2 years ago, I visited Barcelona, and I was in the first class of Fabric Academy, and I was like really into it. I really loved it. So I was thinking of if any Fab Lab in Korea can host Fabric Academy in Korea, and it would be really, really nice. So I want to hear like more about it, and I want to know more about Fabric Academy. So, Yuri, would you please come on?
Thank you. So hi everybody, I'm Fiore Basile. You probably know me from the Fab Academy and for other projects in the Fab Lab network, but this is a kind of very important project for me because this is the first program, let's say global program that is started from the Fab Lab network for the Fab Lab network. So you probably know the Fab Academy. Many of you are instructors, many of you are students, and the Fab Academy was born from a need to enlarge Niels class to a global audience. No, not everybody could go to MIT to attend Niels classes, and all over the world, people wanted to attend these classes. So it was born from a need. The need that started the Fabric Academy, it's another. These two amazing girls, Anastasia Ristofidou and Cecilia Raspanti, for many years before we met, basically, worked on creating a new way of thinking of textiles in the framework of the digital fabrication and all the technologies that we have available now. In Barcelona and in Amsterdam, they founded two textile labs inside Fab Labs. So in Amsterdam, inside the WAG Society, in a very old building in the middle of Amsterdam, and in Barcelona and Poblenou, Thomas showed you a little how this the Fab Lab is located in an old industrial area of Barcelona that has been restarted. In this very two different locations, these two ladies started to explore new ways of creating textiles, new ways of designing clothing, new ways of creating technical textiles, because textiles are not meant only for fashion. They are also meant for doing furniture, for doing basically everything we have around have some textiles. So what's the problem? The problem is textiles and the fashion industry is the most polluting in the world. And this is also the oldest in the world. We are creating textiles from thousands of years. But while the old ways of doing textiles were pretty sustainable for the environment because there were no chemicals involved, now everything that we do with textiles involves chemicals or exploitation. So really our idea is that the Fab Lab network and in general the maker movement can really have an impact in this industry. And the impact that we want to have is to innovate the industry in a way that makes it sustainable for the next 1,000 years. And we can do that through technology. We created this with the format of the Fab Academy, adapted a little. We created a program which is the intersection of digital fabrication, synthetic biology, or biology in general, but also in electronics, information technology, and many other things. And the idea is to train people that can immediately benefit from the training they get. So in a way that they can find a new job, they can create a new job, or they simply innovate their existing job. So our focus is not geeks, is not nerds, but normal people, normal fashion designers, normal artisans, or simply people that look for a way of creating a sustainable living in their own country, in their own area. I come from Italy. Most of the young people from Italy, when they graduate, they have to leave the country because there is no way of having a decent job in decent work conditions and decent pay and opportunities. So how do you do that? How do you change the mindset of an industry? How do you train people that don't have necessarily a technical background to use digital fabrication. We found out that Neil's way, so the Fab Academy way, was a great source of inspiration, but also that we wanted to have the content and experience from the network distributed to other people, like replicated all over the world. So the main difference between the Fab Academy and the Fabri Academy is that every class that you see here, these are all the classes, 13 classes, is taught by an expert from the network. So in some way, it's a way of giving back for all these people to the rest of the network. We have 13 weeks of lecture. The lecture happen globally on Tuesdays. And we have 3 hours lecture and review every week for 13 weeks. And then we decided to have a much longer time for project development. Because, you know, in the Fab Academy, you have just few weeks to do a final project. And that final project can't really be impactful, can't really be your first product that you go and bring to the market. You don't have enough time to do that. Making takes time. A friend of mine always says that. And so we focused on 12 weeks of project development. We just had our final project presentations, and we will have an exhibition at Fab 15 in Egypt with all the work of our students. The 13 weeks of classes basically give the context and the tools to develop your projects. But also we try to have peer-to-peer learning. So we have a local instructor that helps the students. We have global reviews, global experts supporting the student during even for the project development. We have a lot of reviews, a lot of inspiration, and many also recitation by popular designers and people from all over the world. Another thing that we really push is to bring the projects of the students in the international exhibitions. So we had exhibitions in Paris, in Milan, in New York, where the fashion is really, for example, important, where the capital of the fashion. We try to bring the projects of our students. And this is also very important because even if you are very good, if you don't have a good visibility, I mean, it's very difficult for you to break even, to be invited in other places, to find a job, or even to find people that are willing to sell your product afterward. Our faculty, as you see, is very mixed. So we have many people from the network, like Aldo Sollazzo, Adriana Cabrera, me, Anastasia, Cecilia. We come from the FabLab network. But we also enlarge this to global experts, which are really leaders in their field and are willing to test out how it will work to do a distributed education program rather than the standard faculty program. So some of these people work in university. Katia Vega was recognized recently as one of the most influential women in the textile, in wearable technology, and she's coming from UC Davis. Or for example, Oscar Tomigo is a renewed expert in I will show you the slide. I can say that. But basically, he is working on inventing new ways of creating products and services out of these products. Something very similar to what OpenDesk does also. I just will go through the classes very fast. We provide the first class, which is basically the state of the art in the textile industry, but also we try to teach students how to document, how to upload stuff on GitLab. We imagine this as a crash course of what you do in the first week of the Fab Academy for someone that never used probably a version control system. I'm very proud that our students learn very fast the things that maybe in Fab Labs take a few years. We try to give them a practical advice, actionable knowledge, so they don't need necessarily to know all the inner workings of everything, But at the same time, they can immediately use that knowledge and start documenting their projects and start using that technology for their crafts. The second class is digital bodies. We start teaching that we can build your own mannequin, for example. So instead of having a standard fixed sizes for clothing, which was basically invented in first industrial revolution to allow companies build few sizes for all, we teach that each person is different, and with digital technologies, you can just scan the body and create your own mannequin. And we have great examples of that, from people building cardboard mannequins, to people making wood, concrete. Basically, they use everything to do the mannequins. But in this class, they basically learn 3D scanning, laser cutting, milling, all these things in 1 week. They can basically start and use all the machines in a lab. And most importantly, this is the first class where they are approaching the lab, and so they learn also the safety rules for the lab. This is very important. The second class, and this is also very nice because you can have a workshop this afternoon on this class. It's called Circular Fashion, and the idea is to create the basis for hacking the fashion system. So instead of buying a cloth, which will be the same forever, you can design something that can change shape, that you can combine with another garment, that can become something else in the future. Instead of throwing it away or making it into powder and new materials, you can basically just disassemble it and assemble it. And during the workshop, we show few examples of how to make your own interlocking system for creating modular clothing. And the students basically learn how to design parametric models that can create modular patterns that allow you to basically build Lego blocks for fabric. One of the issues about pollution of the fashion industry is dyeing. So they say when you have something black, someone was dead because of that. Because the dyeing black color is something that is not natural. There is no way for doing natural black color. We are all dressed in black. It feels very hypocrite on this. But still, I mean, we need to start on something. The biogrounds is the class where we teach natural dyeing. So to make a nice red, you can use the onion skin and boil it in water and pour your clothes into this onion soup, and you will get a reddish color. And the nice thing about this color is that it will change in time. Every time you wash it, it will lose some color. But then it's very easy because you can just dye it again. And the same you can do with so many things. So the nature gave us all the pigments that we want for creating colors. It's just that it takes a little more time and maybe money to do it rather than doing industrially with paint. But at the same time, this is a way more sustainable. And for dyeing, we also use bacteria. Since this process started in the WAG Society, they had a nice biolab. So they started using mycelium and like other bacteria that produce a natural dye that you can use for your clothes. So there is, you see, there is a lot of intersection between all the programs that we do, all the labs that we have. The e-textile class is what you expect to be a wearable technology course, no? So we start with soft sensors, like how you can create sensors and actuators that are soft and don't use necessarily like silica, but they use conductive fabric, they use conductive thread, and they use insulating sheets. And all these are connected to the ATtiny. We have Liza Stark, which is a renewed expert in wearable technologies, and she teaches these two classes in the course. This is the first module where the students only learn to make soft sensors and actuators, and then there is another class where they learn how to program and network them. Okay, no, I'm going backwards. Okay. Another important part of textiles is also fabricating new kind of textiles. Probably all of you know that we can use fibers, we can use mushrooms, we can use many different gelatin, for example, to create new materials. And most of these materials are biodegradable, so they are not really suited for making a swimming suit, because you will be naked after, but you can use them for example, to make a bag that is fully biodegradable, just cook with a kitchen. So one of the requirements for the labs of the Fabricademy is to have a kitchen. And this class is beautiful because it produces so many different, every time you try to do a new material, you will come up with a different one. Even if you have a recipe, and we are collecting recipes from all over the world, every time you make a recipe, you will get it different. No, even when you cook food, it's difficult to make the same dish every time. And so this brings uniqueness and personalization somehow. We all got the wallet from the Philippines guy, and every single wallet was different because the material, it's random, no? Okay, so the next class is a more geeky one, but applied to fashion. It's called Computational Couture. And also Aldo Sollazzo teaches how to use Rhinoceros and Grasshopper to create parametric models or generative patterns that you can actually either 3D print, mill, or a combination of the two to create very nice garments. If you remember in Santiago de Chile, we had the fashion show with many dresses that were done in like 1 hour and a half before the exhibition using the laser cutter, thanks to this technique. And while this looks complex, you don't need to be an expert in Grasshopper to design something. We provide some basic designs that people can customize, and if they are expert, they can improve them or create their own. But we got really nice designs for this. The textile scaffolding instead, it's ways of creating, of modifying textiles, of shaping textiles, using very similar techniques that what we use for furniture, for example. So we use compression, we create composites, we do crystallization, so growing crystals on top of materials to decorate them. We do the fabric formwork, so you use pressure to give a shape to textiles. Like, for example, there is a bag which basically falls into itself and can open based on how much stuff you put in it. And this deformation is all programmed into the material using compression. So nothing chemical, just physics, basically. Of course, we couldn't be a program of the FabLab network without having some machines. And what we try to teach in this class by Mar and Barbara, it's an artist duo that started the first open source knitting machine project. They teach how to turn fibers into fabric. And this can be done by hand, but of course can be done by machine. So the assignment in this class is to either hack a machine or build your own machine. And we had a lot of interest in different kind of machines. Of course, most of the people are not very technical. So even hacking a machine, adding like for example, an Arduino to an embroidery machine, it's an hack. But it feels very empowering because, again, this is not meant for engineers. This is meant for non-technical people. This is the second class on wearables. And in this one, we work on, for example, digital sensors, so how to use an accelerometer, how to combine several sensors into a single information flow and make sensor fusion to do something to recognize activities, how to develop interfaces for your wearable projects. There are so many things going on at the moment on wearable. And this is one of the fastest growing markets in electronics in general. Each of us has probably some wearable thing within. But what we want to do is try to teach this to the people that actually design the garments or design the textiles. So this has much more power. Again, like a designer that can control all the process of the production, but also the design of something more interactive. And then we have this class about implication and application, where we see what is the state of the market. How do you really can make a business out of a single piece of textile or a collection? Adding something that is personalization, because now everybody wants something personalized. How do we create a value chain out of a single product, creating a service around it? Wearables for healthcare, for example, all have an app that allows you to track your motion and upload to the cloud your data so you can graph. And then you can buy different wearable pieces that all talk to the same cloud platform and collect data. All of these are basically, for example, one example of Oscar research with Troy Nactigal, which is a friend of ours and one of the also the global mentors, let's say, was about creating your own shoes from a parametric model. You went to a booth, took a scan of the sole, extract a 3D model from that, and then generate laser cutting files for creating your upper sole and 3D print the lower sole in rubber. So this is a system for create, like Nike doesn't have that. But still, with open source, we can do it pretty fast. And this class about soft robotics, this was actually a suggestion by Neil to add this class in the beginning, the first year. This is very interesting because simply with a vinyl cutter and a heated press, you can create controlled deformation on textile, on fabric, using pneumatic systems. And if you get like a small pump, the ones that they use for measuring the pressure in your arm, you can disassemble it, take just the motor, and hook it to your inflatable, and you have a portable inflatable. There are many examples of dresses like that they open up with spikes to protect your personal environment, your personal privacy. But of course, this is the basis of many other also bio and healthcare related applications. For example, for helping you making one movement or for alleviating some pain that you have. Finally, this is the craziest class because we have a class on skin electronics. It's teaching how to bring electronics closer to the body. And Katia Vega teaches how to make e-makeup, for example, so to apply electronics on your skin with the same techniques that they use in special effects or for movies, or how to embed NFC tags into your fingernails so that you can open the doors or control or pay your coffee without getting your card out. And even if this looks a bit strange, probably this is one of the biggest future applications of wearables, like embedding electronics into the body directly, because it has lots of also application on the health. For example, you can create something that you wear that has sensors inside that measure your glucose levels if you have diabetes. And you don't need to have something external that you have to charge and bring, because they are thinking of ways also to power these electronics out of the electricity that we have all on our skin. Okay. Finally, we have a global community of labs. So the nodes, this is the list of nodes for 2019. So for the class that will start in September this year, we run from September to March. And in Asia, you currently have Chandigarh and Kamakura as nodes. But of course, we are always open to find new nodes because this program doesn't have very high requirements in terms of infrastructure. If you have access to a Fab Lab, it's okay. It's not necessary you to be a Fab Lab to host Fabricademy. We had participants that were artist studios or even individual designers that had close by a lab that they can use. And of course, I invite you to find out more about the program and if you are interested to apply as a node. And finally, as we are starting in September, this is the best time, also the only time, where you can still apply to be a student and become part of this great family, which is the Fabricademy. If you can show just the website is, okay, stop a second. We work in open source, so all our content is open. You don't need to pay to get our content. We ask for a registration fee, which is the same as Fab Academy, for providing you feedback, evaluation, access to the lab, and all these things. But if you are just interested out of curiosity or want to experiment by yourself, we have about 200 videos lasting 1.5 hours. So it's a huge quantity of content. It's 2 years of classes and reviews and project presentation. So you can become really an expert just watching the videos on Vimeo. And on the other side, class, okay, in the Textile Academy, if you click on the wiki, don't do it because it doesn't show really well on this resolution. You can find all the lecture notes, all the assignments by the students. Okay, don't worry. It's linked there in the wiki. And the last thing, if you just click on bootcamps, we are leaving Saturday for Iceland, where we lost 1 week of bootcamp, where we will visit wool factories, silkworm factories, fish leather factory, and also we will run 40 hours of classes live with all the founders of the Fabricademy and many experts around the world. It's a bit late to book for Iceland, but all the things that we will do in Iceland will be recorded. And we will publish it on Vimeo. So if you are curious about what looks like a bootcamp of the Fabricademy, you just go on Vimeo in the next few weeks and you will find everything. And if you have any questions, the website is textile.academy.org. info@textile-academy.org is our email. Just send us an email, okay? Thank you.
Thank you. You can find here a project pad, first floor textile workshop. I think you can also try some workshop related to Textile Academy. I have one announcement about the field trip to Ulchiro and FemLab Seoul. We are going to do it after dinner. So the dinner will be in the food lab you had 2 days ago. We are going to have dinner at 5:30. After that, 6:30, Tex. Can you stand up and say hello to everyone? So Tex will going to lead you to FemLab Seoul, and he cannot lead everybody, right? So half of you will go with him, and the other half of you will go with you. Okay? This is not a mandatory thing. For those who wants to go, you can go with him. Yeah, that's it for the announcements. We're going to have lunch. Where the first floor of the idea bridge, the outdoor place for kitchen. Yes. Thank you.